Hey mathematicians, so in problem number 1, here's what they're going for. So remember that equivalent just is the big kid word for equal to. And A is not going to be correct. And the reason A isn't correct is because they did 8x divided by 2 and got that 4x, but they did not also do 7 divided by 2. They just left it as a 7. So because they didn't divide both of those terms by 2, A is not equivalent to the original problem. B is equivalent to the problem because if you multiply, because if you multiply by 1/2, that is exactly the same thing as dividing by 2. And then everything else in the two equations is the same. Letter C is also equivalent because you do 8x divided by 2 to get 4x, and then -7 divided by 2 got you that -3.5, and then the -4 just stayed the same. So C is also equivalent. Letter D is also a no because in the original problem, they took the 8x minus 7 and they divided it by 2. But in this version, they did not. It would be okay if they didn't divide by 2 as long as the right-hand side wasn't also the same. So D is not equivalent. And E is an example of what I'm talking about. So for E, so here was the original problem. So what they did is they canceled out this dividing by 2 by multiplying by 2 so that it canceled and the divided by 2 was no longer there. And this is equivalent because you can tell from E, they multiplied the left-hand side by 2 and they also multiplied the right-hand side by 2. That's where the -8 came from. So because they did multiply both sides by 2, E is also equivalent. So for number 1, options B, C, and E are equivalent. Click on the video that is by this problem on the Class Kick Study Guide if you want to see a little bit of a shortcut for what you could also do to verify that these are not equivalent. And that shortcut involves using the Desmos graphing calculator. Okay, for number 2, A is not an option because everything is the same in the two equations, except they randomly changed that 6 to a 3. So because everything else is the same except for that one random number, A is not equivalent. B is equivalent because remember there's a -1 technically on the outside of those parentheses. So if I distribute that -1, I get -2x plus 6. And then if I bring down my 7 and combine the 7 plus 6, I should get -2x plus 13 on the right-hand side, and that is not what I have here for B. I'm sorry, I think I said B was equivalent, and B is not, because if I distribute and then combine those like terms, I do not get the right-hand side. C is equivalent partially for the reason I just mentioned, that if I distribute this right-hand side and I get -2x plus 6, and then I add the 7 to it, the right-hand side gives me that -2x plus 13. And then you can see here that 6x divided by 2 is just kind of rearranged like this, and 5 divided by 2 is just so the left-hand side is just separated into 2 separate pieces, but they are still equivalent. So C is an equivalent measure, an equivalent equation. And then D is not, for the same reason we've already mentioned, that if I distribute and combine like terms on the right-hand side, I should have gotten negative 2x plus 13 instead of that negative 2x minus 1. So for number 2, C is the only equation that is equivalent. And again, check out the extra video that I made that shows you how you can use the graphing calculator to do number 1 and number 2 for you. Okay, for number 3, this is one of those problems where they write you a big old paragraph, but really there's not much to it because they actually give you the equation to use. So it says, which equation can be used to find the time? And it says the time is measured in months of service. So, and it says to use T for time. So since it's asking us to find the equation that would help us find time, it's basically saying it wants us to isolate the T. So let's figure out which one of these equations has the T isolated correctly. So I'm going to copy the original problem down here, and I am going to subtract P from both sides because I know that I need to get the T by itself, and so that means that the P needs to get off this side of the equal sign. So I subtracted P from both sides. Now we can't combine a C and a P because they're not like terms. So I'm just going to write them as 2 separate parts over here on the left-hand side. And then finally, how am I going to cancel out the M? Well, I'm going to do that by dividing, and I need to divide the entire C minus P by M. So now my T is isolated. So I'm looking for the one that has C minus P divided by M, and that is going to be option A right here. Okay, for number 4, it's asking us to interpret which of these statements is true. So option A, if no vans were needed. So where are no vans? Well, no vans is right here at the bottom of the y-axis because that is where the vans are. And so this would be 0 vans. Well, how many cars line up with 0 vans? Well, if you don't have any vans, then you would need 20 cars according to the graph, but this says 13. So A is not an option. That's correct. Option B is asking if no cars were needed. So cars, this is where 0 cars would be. And how many vans correspond to that? That is like halfway in between 12 and 14. So that is pretty close enough for me for 13. So B is correct. Also, for the same reason that A was not correct, that is why C is correct, because it said if no vans were needed, there would be 20 cars needed. So B and C are correct. Okay, D says if 14 cars are needed, so here's 14 cars, that means that 4 vans will be needed. And, yep, there's a coordinate right here that lines up with 14 cars and 4 vans. So D is correct. And then finally for E, it says if 2 vans are needed, so 2 vans, that means that 12 cars. Well, let's see how many cars line up. Nope, this is halfway in between 16 and 17. So if there were 2 vans, we would actually need 17 cars, not 12. So E is not correct. So you should have B, C, and D for number 4. Okay, for number 5, it says to write an equation that represents the cost of a t-shirt. So I can actually use whatever variables I want, apparently. And so first of all, what is it that I don't know? Well, each letter, we don't know how many letters we're going to do for the t-shirt. So I'm going to make each letter X. And because each letter costs $1.25, I represent that as $1.25 times X for each letter. Then it says each number, I'm going to make that Y, costs $2.50. So the cost of each letter plus the cost of each number is $2.50 times y, plus each t-shirt costs $15. So I need to add $15. So all of this added together equals the total cost of my t-shirt. So on the test, if you just kind of annotate your problem like this so that I can see what you want each variable to represent, you don't need to write me a big long thing. This will totally work. Okay, for number 6, I am first going to graph my top equation. It is in slope-intercept form, y equals mx plus b. So my b, my beginning point, is -4. Then if I look at my slope of my line, that positive 1/2. So it's positive. And because my rise and my run is 1/2, and it's going up, that means that from my beginning point, it's going to go up 1 and over 2. I'm going to make a nice straight line using a ruler. And then to graph my bottom equation, first, I've got to actually get this equation into slope-intercept form. So remember that is y equals mx plus b. So my x needs to go over to the other side. So to cancel out that minus 5x, I'm going to do plus 5x. And I'm going to do it on both sides. So I've got -5y is equal 5x plus 5. I put the x in the front because in slope-intercept form, the x does come in the front. But because this has an x and this doesn't, I cannot combine them. So I got to leave them separate. Then I'm going to divide everything by -5. So this becomes y equals, if I do 5x divided by 5, that gets me a -1x. And then if I do 5 divided by 5, sorry guys, my allergies are terrible today, that will give me a -1. So my b, my beginning point, is -1. And then my slope is a -1. So that means it's going to go down and over like this. To make my line. And my solution is right there where they intersect at 2, -3. And remember, you're allowed to use the Desmos calculator, and it will help you to figure out whether or not you are graphing it correctly. All right, so for number 7, it says to solve it without graphing. Now, you can still use the graphing calculator to check and make sure that you did it correctly, but you need to be able to do this algebraically. Now, what I don't like about this problem is that it's not set up for substitution because I don't have any variables that are isolated, but it's also not set up for elimination either because your x's and your y's and your constant are not nice and lined up. So to me, I feel like it would be easier to get the terms lined up so that I can solve it by elimination. So what I'm going to do is get this 2x over to the other side of this equation. So I'm going to do that by doing a minus 2x on both sides. So that'll give me -2x plus 3y is equal to 12. So then I'll take the other equation and write it underneath here. So now it's pretty well set up for elimination. I do have an issue though. They're lined up, but those are both positive. So if I add those together to eliminate, they won't cancel. So I'm going to multiply my top equation by -1. So what that's going to do is it's going to turn that positive 3y to a negative 3y so that then I can combine it with this one and they'll cancel each other out. So I'm going to rewrite that top equation, multiplying every piece by -1. So that gets me a positive 2x minus 3y is equal to -12. And then I'm just going to rewrite the other equation here underneath it. So when I add those together, those will cancel. This gets me 5x -12 plus 12 is equal to 0. Divide both sides by 5. X is equal to 0. Now, of course, I can't graph a coordinate with just an x. I also need a y. So I'm just going to take the top equation. So the 3y is equal to 2x plus 12. So I just took this top equation, and I am going to substitute 0 for x. So instead of 2 times x, I'm going to do 2 times 0. So that gives me 3y is equal to 0 plus 12, which is 3y is equal to 12. And finally, divide both sides. Y is equal to 4. So that means my solution for A, because you put your x coordinate first and your y coordinate second, is 0, 4. Letter B is not set up for elimination or for substitution either, because we don't have any variables isolated and we don't have our terms lined up. This time, I think it's going to be easier to solve by substitution, because if I move that 2y over to the other side, then I'll have an isolated x. So that is what I'm going to do for this one. So I'm going to, again, move the 2y over to the other side by doing a minus 2y. So x equals -2y minus 1. So now that I have my x isolated, and I know that the x is equal to -2y minus 1, I am going to take the other equation, and I'm going to remove that x, and I'm going to replace the x with a -2y minus 1. So I'm going to rewrite the entire equation. So 4y is equal to -3. I'm going to substitute in the -2y minus 1. Sorry, I did not give myself room here. Here, I kind of scooted it down here a little bit. So again, where did this equation come from? So I took this top equation and I wrote 4y equals, so everything is exactly the same, except I took out the x and I replaced it with the -2y minus 1. So now I need to distribute, so 6y plus 3. I'm going to bring everything else down. And 3 minus 3 is going to be 0. So now I have 4y is equal to 6y. So in order to isolate the y, I have to get the y's on the same side of the equal sign so I can combine them. So I'm going to do minus 4y on both sides to get rid of the 4y over here. So that gives me 0 is equal to 2 times y. I'm going to divide both sides by 2. So that gives me a value of 0 for y. So now that I know that y is equal to 0, I'm going to take this equation that I had the x isolated in, and I am going to replace the y with a 0. So -2 times 0 is 0. 0 minus 1 is -1. So my solution for B is going to be -1 and 0. Okay, so for part A, for number 8, it says to find the solution without graphing. So since my x's and my y's and my constants are nice and lined up, I'm going to solve this one by elimination. Now, right now, I don't have anything that would cancel out if I added these together. But I notice there's a 1 in front of that y. And if I multiply this bottom equation by -2, that will change this to a -2y, which will cancel out with that positive 2y. So I'm going to multiply everything in the bottom equation. And I'm going to bring the top equation down. So now I'm going to add those together. That'll cancel. Leave me with -2x is equal to -4. Divide both sides by -2. So my x coordinate is a +2. So now that I know that x is equal to 2, I'm going to take that value for x and I'm going to substitute it for x in the top equation. So instead of 4 times x, I'm going to do 4 times 2 plus 2y is equal to 8. So 4 times 2 is 8. 8 plus 2y is equal to 8. I need to isolate my y, so I'm going to subtract 8 from both sides. 2y is equal to 0. Geez, we got a lot of zeros on here. So my y is equal to 0. So my solution is my x of 2 and my y of 0 for 2, 0. So I found my solution, and now for part B. It says if we multiply the second equation by 2, we have this system. So if we multiplied the second equation by 2. So it says, why does this system have the same solution? And you can say something along the lines of this. As long as it's pretty similar on the test, I'm good. So because you multiplied everything in the bottom equation by 2, you made what's called a balanced move, right? So you multiplied everything by 2. So since you multiplied both sides by the same value, so the equation is equivalent to, I guess I should say the new equation is equivalent to the original. And again, the reason for that is because I did the same operation to both sides. So I kept the equation balanced. So that explains why they would have the same solution, because the two equations are equivalent. Okay, last but not least, C is asking if we add these two equations together. So we get 4x plus 6x would give us 10x. We could do 2y plus 2y, which gives us 4y. Oops. And then 8 plus 12 gives us 20. It says, is the same ordered pair the solution to the system? Your answer is yes. And the reason for that is because you added equivalent values to each side of the equation. So what I mean by that is this side of the equation is equal to this side of the equation, and we know that because the equal sign is right there. So because we added two values that are equal to each other to each side of the other equation, then that means that the new equation you got from adding them together is also going to be equivalent.